time can be both fleeting and seemingly endless. It is all from one's perspective. Our lives can appear quite long, but in cosmic terms they are insignificant. Cosmic time is long, exceptionally long. But both the fleeting and seemingly forever still are based on time. But did you know that time itself changes once you leave the Earth? Could this change in time explain gravity and prove that limited time travel is possible? Yes, possible, but in a limited sense. As a result of Albert Einstein's theory of general relativity, not the more commonly known special theory, it is now common scientific knowledge that GPS satellites in geosynchronous orbit, 22,236 miles above the Earth, have clocks that are designed to run slower. Yes, slower. GPS satellite clocks would gain 45 microseconds a day, every day, if it were not for the purposely adjusted clocks. So what are 45 microseconds? Isn't that silly small? Isn't that a fleeting moment in time? Let's revisit a time, say, 100 million years ago. But you may think, wow, 100 million years ago? But the Jurassic period started almost 200 million years ago, and life began about 3.5 billion years ago. Now imagine if a GPS satellite with a normal clock was somehow put in orbit at that time. Since the imaginary satellite was put into orbit 100 million years ago, the very small 45 microseconds a day now become much more noticeable. After a mere 100 million years, the normal clock on the imaginary GPS would show almost 19 days in the future compared to time on Earth. If we do the same simulation but use the moon instead of a GPS satellite, and instead of 100 million years, we use the approximate age of the moon of about 4.5 billion. Since the moon is even further away, time progresses at a much faster rate than the satellite. After its 4.5 billion year life, the calculation would put the moon at an astounding 3 years in the future. But why don't we see the 3 years difference? Astronauts have been there, and they didn't seem to be affected. The only explanation that matches the math is that they traveled 3 years into the future to get there, then traveled 3 years back in time to return to Earth. This would also be the case for radar or laser rangefinders bounced off the moon. This shows that limited time travel is not only possible but happens all the time. But the Earth is small and its time dilation is also small compared to much larger bodies such as our Sun. About 1.3 million Earths can fit inside the Sun. Time dilation is much greater there. This has the effect of the Earth traveling through time about 1 minute more per year than the Sun. Once again, that still sounds a bit small. Again, for perspective, I will use the same time frame as before of only the short 100 million years. In a 100 million year cosmic time scale, the Sun will lag behind the Earth by 100 million minutes. Since the Earth is over 4.54 billion years old, it would calculate to Sun falling around 8,600 years behind us. Yes, that number is right. Do the math on your own if you don't believe it. What if we had an incredibly long tower that started here on Earth and reached even halfway to the Sun? That would mean that one end of the tower on Earth would be in the future compared to the other end that would be approaching 8,000 years in the past. Since each end of the tower is in extremely different time zones, what effects would that have? Could this lead to a final explanation of gravity? This will be explained in more detail in further videos from time factor theory. We will also explore what will happen to the universe as time dilation takes its toll over millennia. What effects does this also have inside a black hole? Could this effect be the cause of gravity and not the other way around? Could this explain dark matter, dark energy, accelerated expansion, and more? But most will say that scientists already have the right equations, and maybe they do, but just a little inverted. Is move 1 meter in 1 second the same as in 1 second move 1 meter? The latter allows time to become a variable, as well as proven repeatedly by relativity. This alternate view of math allows time factor theory to be compatible with current theories. Although the exact math needed is slightly more complex, this explains the basic premise. Please share this video, hit the like button and subscribe to get notified when the next video time factor theory, time for more time is released.